Hello and welcome to another WJEC A level physics question. This is an old one from way back in 2005. It was the Unit 2 question 3. It starts by referring to two isotopes of neon and asking us to define the term isotopes. So we're just going to go with atoms of the same element with different numbers of neutrons. Next, we're asked to explain quantitatively, using the examples above, what our definition means. Well, the top number tells us what's known as the mass number, or better in physics terms is the nucleon number of the element, which is the total number of protons plus neutrons in the nucleus. So the neon 20 has 20 protons and neutrons in total. The lower number, 10, tells us that there are 10 protons. This number is known as the proton number or the atomic number. So neon 20 will have 20 take away 10, which is 10 neutrons. And the neon 23 will have, neon 22 will have 22 take away 10, or 12 neutrons. Next, the question looks at a simplified energy level diagram for neon atoms and explains to us that in a certain type of laser, electrons are raised from the ground state to the energy level marked L, and we're asked to calculate the energy needed to do so. All we need to do is look at the difference between the numbers on the diagram, and 34.44 take away 1.44 just gives us 33 times 10 to the minus 19 joules difference. So that will be the energy required. We're told that later on, when stimulated to do so, the atom emits radiation of wavelength 633 nanometers, and we're asked to explain, or simply state rather, the part of the electromagnetic spectrum in which that wavelength lies. If we remember that visible light is from roughly 400 to 700 nanometers, it's clear that the 633 nanometers is part of the visible spectrum. Might be asked colour. Colour is roughly red. Next, we're asked to calculate the photon energy for that particular wavelength of light and show that it's 3.13 times 10 to the minus 19 joules. So here we're just going to simply use the equation that's not in the WJEC data book, that E equals hc over lambda. H is 6.63 times 10 to the minus 34. Speed of light 3 times 10 to the 8 meters per second. And the wavelength is 633 nanometers. Mustn't forget nano is 10 to the minus 9. If we put those numbers into the calculator, we actually get 3.14 times 10 to the minus 19 joules. And a slight difference in the answer there is simply due to the fact that back in 2005, the value of H was only given to 2 significant figures rather than the current 3. Next, we've got to draw an arrow on the diagram to show the transition between electron energy levels which occur when a photon of that energy is emitted. So we're just looking for a difference between energy levels of 3.14 or 3.13 in this case. And that will be between the top level that we've already highlighted and this level, a couple of levels down. Because the photon is emitted, it means that the electron transitions downwards, and the arrow has to be downwards. Thank you very much for listening. Please remember to like and subscribe.